So this is summer 23 paper 1-2 question number 1. A stone sinks in water. What is the possible value for the density of the stone? So you know that if something is going to sink, this means that it's going to be more dense than water. Now for doing this question, you need to know that the density of water is 1000 kg per meter cube. So whatever this stone is, it has to be more dense. So what is the possible value for the density of the stone? 8 into 10 to the 2 is 800. So it definitely can't be this. 2 into 10 to the 3 is 2000. And then other values are also in the thousands range, but if you look at those units don't make sense, right? It's Newton per meter cube, right? So this one, in which you look at question number 1, if you look at this one, you see that Newton per meter cube is not a possible unit for density. So 800 can't be the case because it's less than 1000. We need something which is more than 1000. So the only possible answer is B, right? Easy. Question 2. Gigameters, terameters, micro and pico are all units of length. Which unit is the largest? Which unit is the smallest? Tera is 10 to the 12, giga is 10 to the 9. So tera is larger. And the smallest one is pico, which is 10 to the negative 12. So this is D. Question number 3. Two measurements for a solid sphere are shown. So you have mass, you have the diameter of the sphere. These values are used to determine the density of the sphere. What is the percentage uncertainty in the density? So you know density is mass over volume. And in this case of a sphere, the volume is 4/3 pi r cube. And again, you know that what is given here is diameter, not the radius. But the idea is if something can be multiplied or divided by 2 to get another thing, or by any other constant for that matter, it's going to have the same percentage uncertainty. And you can try this out as well. If instead of r you write d by 2, right? So it's going to be d by 2 cubed. So that would be d cube over 4/3, and the over 2 would become an over 8. So that would become 4/24 pi r cube, right? So the idea here is that if I want to calculate the percentage uncertainty in rho, it's just going to be the percentage uncertainty in m plus 3 times the percentage uncertainty in r, right? So this is what it's going to be. So percentage uncertainty in m, 0.1 over 32.5 times 100 plus 3 times this entire thing, 0.04 over 1.87 times 100, right? And then you just calculate this. So the answer to this one, all right, so the answer to this one is supposed to be D. All right, this is also really straightforward. Question number 4. An aircraft travels along a horizontal path. Two of the forces act horizontally on the aircraft, which are the thrust force of the engines and the force due to the wind. Vector diagram for these forces is shown. Which vector represents the resultant horizontal force acting on the aircraft due to these two forces? Don't make the mistake of joining these, because these are both basically the tails of the forces. What you can do is you can superpose any one of these. So if I take this one back, so you can see that now this is the head of the first one, tail of the last one. So I can just join these, and you can see that it's supposed to go like this. So the only possible answer here is C. Some of you might also be so good at this that you don't even need to superpose the vectors. You can see that because this one has a, basically you might also be able to see, just because of the parallelogram rule, that the resultant would be along this direction, right? If I just pick this up and superpose this here, so it would be along this direction. Question number 5. A ball travels from point X to point Y around a semicircular track of radius 1 meter as shown like this. What is the displacement of the ball from X to Y? So X to Y, remember the displacement is the shortest straight line distance. So this would be the distance, but the displacement would just be this. So of the displacement from X to Y, so from X to Y is this, right? So it's 2 meters because the radius is 1, so this is really 1 and 1. So it's 2 meters due south. Because this is a vector quantity, technically you should be giving the direction with this. Alright, so finally we have a question which is somewhat complicated. A rock is launched vertically upwards from the surface of Earth, and an identical rock is launched vertically upwards from the surface of Mars. Each rock is launched with an initial velocity of 12. So according to my equation of motion, I know this is u. Each rock then reaches its max height above the surface before returning back down to the surface. The velocity time graph for each rock is shown. In both cases, air resistance is negligible. What is the difference in the max heights of the two rocks? So I guess because the graph is given, the easiest way to do this is first to identify when are the max heights going to be reached. So the idea is this, that the max height is reached when the final velocity is 0. So the final velocity is 0 here and here, right? So for this final velocity being 0, we can calculate what distance it covered in going up to that max height, which is really the max height, and you can find that out. So this starts from 12. This is, so I need to read this axis now. So this would be 1, this would be 1.2, 1.4, 1.6, 1.8. So this is half into 12 into 1.2, right? This is for Earth. So what's the max height in this case? It's just going to be 6 times 1.2. Let's see what that turns out to be. So that is 7.2. And then I do the same thing for Mars. So this is the max height in that case. So I would need all of this area. So this is still 12 and we need to find this out. So this would be 3, and then this is 3.2. So 3.4, 6, 8. So this is 3.2. So half into 12 into 3.2. So this is 6 into 3.2. So 19.2 and minus 7.2. That's what? 12. So the answer here is 12, right? So the answer to 6 is A. All right. Let's go forward. Which statement describes the mass of an object? Again, we know that mass is basically, so you know mass is basically its resistance to changes in motion, right? So that's C. That's how mass is basically talked about in higher level science. In your earlier education, you might have talked about mass as the amount of matter in an object, but now we talk about this in terms of the resistance to its changes in motion. Question number 8. A submarine of total mass 3200 kg is at rest underwater. Total mass of the submarine is suddenly decreased by 200 kg by pumping water out of the submarine horizontally in a negligible time. Right? So this is pumped out in almost no time. Upthrust acting on the submarine is unchanged. Change in the total weight of the submarine causes it to accelerate vertically upwards. What is the initial upwards acceleration of the submarine? So the idea here is this, that initially it was at rest. So this means the vertical forces were balanced. So in this case, previously, this was the weight and there was the upward upthrust. And upthrust would really be equal to the weight, which would be 3200 times 9.8. Right? This is what the upthrust was before. Let's calculate this. So 31,360. This is what it was before. And now the mass is decreased by 200 kg. So the weight has now gone down. So I can find out this new weight because I know this new mass. So I can find out the new weight. The new weight would be 3200 minus 200. So 3000 times 9.8. So 3000 times 9.8 is 29,400. Now I also know that the upthrust is the same, but the weight is now less. So there is going to be a resultant upward force, which is basically causing it to accelerate vertically upwards. So if I use Newton's second law here then, so I have resultant force equals ma. So 31,360 minus 29,400. What mass would we use now? Again, we would use the new mass, which is 3000, because that's the new mass. That's what, that is the mass which accelerates upwards. 3200 was the older one, equals to 3000 A. So 31,360 minus 29,400 divided by 3000 is 0.6533. So 0.654 is what we're going for, right? So the answer to this one is B. All right. Question number 9. A box in air slides with increasing speed down a rough slope from point P to point Q. Increasing speed basically means acceleration, and according to Newton's second law, this implies there is a resultant force. And there is a resultant force downwards. Right? So there is a resultant force downwards here. So the slope exerts a constant frictional force on the box. Right? So there is this frictional force which is constant. It says as the box moves from P to Q, there are changes to the magnitudes of its acceleration and the total resistive force acting on it. Now, this word in itself is giving you a hint that it's not just talking about friction now, it's talking about the total resistive force. And it also says this box is moving in air. In air is a hint for you to consider air resistance. Because it is speeding up here, air resistance would increase, which would make the magnitude of the total resistive force increase. And when the total resistive force increases, there is going to be this downward force, which is going to decrease the acceleration. All right. Question number 10. Two balls X and Y approach each other along the same straight line and collide. The collision is perfectly elastic. Initial speeds are ux, uy respectively. After the collision, they move apart with speeds vx and vy respectively. Collisions are shown. Which equation is correct? So in doing so, I hope all of you guys can identify that we are supposed to use the relationship that the relative speed of approach equals relative speed of separation for elastic collisions. Here both of these are moving towards one another. So if you remember the rules, if they are moving towards one another, the speeds will be added. And afterwards they are both moving away from each other. Again the speeds would be added. When they're moving in the same direction, speeds are subtracted. When they're moving in opposite direction, speeds are added. So it's going to be A, right? ux plus uy equals vx plus vy. 11. A rod is pivoted at point O. A force F is applied to the rod at point W as shown. What is the moment of the force about O? So this is the force F. What is its moment about O? So again, always remember, I was just doing an O-level class. I taught them exactly this same thing. Think of this force as being an infinite line, and think of what the shortest distance is. Because what we know from trigonometry and math is that the shortest distance is the perpendicular distance. So with this being a very long line like this, the shortest distance would be the perpendicular distance, which would be this. So it's the force F times the distance OY. Alright, question 12. A uniform rod XY of weight 10 Newton is freely hinged to a wall at X. It is held horizontal by a force F acting from Y at an angle of 30 degrees to the horizontal as shown. What is the value of F? Again, really straightforward. You guys can obviously identify that first we would have to resolve this force. This component would be sine 30. This one would be cos. Again, I'm not really interested in the cos because it won't create a moment because it's passing through the hinge, right? What is the value of F? Now, this question has also been asked in the past. The idea here is that some people will be confused by this because some people might think that F sine 30 just equals to 10. This is wrong. Because in doing so, you are not considering the force which acts here. And by the way, I don't know whether this is upwards or downwards, but I do know there is some force here. So the next idea is to use the principle of moments. With the principle of moments, the idea is that you are not given any distances. And the catch here is that you don't even need those distances. If this is a uniform rod, this means its center of gravity is right in the middle. And this weight is obviously right in the middle, and the force F is acting at the extreme end of this rod. So if I have to mark some distances, I would probably mark this as D and this one as D as well. So what I would then write as the equation here, I would say that the moment of the 10 Newton force would be 10 times D, and this one would be F sine theta times all of this distance, which would be 2D. So F by 2 times 2D. So F is just 10. All right. That's the idea here. Question 13. Two solid cubes X and Y are made of material of the same density. Cube X has twice the mass of cube Y. Cube X has sides of length X. Cube Y has sides of length Y. What is the ratio X over Y? So I'm thinking this, that density is mass over volume. Right? Density is mass over volume. I need the ratio of these lengths, which I don't have right now. What I could do is I could find the volumes and take their ratio. And because I know that volumes are basically calculated for cubes using either cubing these sides, I could take the cube root of these volumes, and that would give me the ratio of the lengths. All right. First, let's do this. So again, we can say we need the ratio of X to Y, which is the, which is the ratio of the lengths of X to the lengths of Y, right? So mass of X is twice. So again, if I'm writing it like this, first I'm doing Vx, ratio of the volumes is what I'm doing first, Vx over Vy. So volume of X would be mass of X And I would write density of x, but they have the same density, right? So it's over rho, and Vy would be My over rho. So rho's cancel out. So Vx over Vy equals to Mx over My, which we know is 2 over 1 because it's double. And now because I need the ratios of the length of x over length of y, what the examiner calls x over y, I know it's going to be the cube root of Vx over Vy. Right? So I just take the cube root of 2. So I think this should be A. This 1.41 is the square root, so cube root should be A. Alright, a pretty tricky question. You just had to recognize this relationship of the cube between the lengths and the volume, right? Alright, question 14. A U-shaped glass tube contains liquid of density 2000 kg per meter cube as shown. What is the difference in pressure due to the liquid levels between P and Q? So what is this difference in pressure? So for difference in pressure, remember that you use rho GH, obviously for the liquid pressure. You have 2000 given, G would be 9.81. And the difference in pressure is basically due to that difference in height, which would be 10 minus 6, which would be 4 centimeters. So 4 into 10 to the negative 2, right? So let's see what this turns out to be. 2000 times 9.81 times 0.04, so 784, so 780 pascals. 15. A steam turbine is used to drive a generator. Input is PL, output is P naught. Loss is, input is PI, output is P naught, and loss is PL. What is the efficiency? Efficiency is output over input, so PO over PI. Again, pretty easy. This could have very well been a O-levels question. A variable force is applied to ensure that a constant power is supplied to a train. Which graph best shows the variation of force versus velocity? So the equation that comes to mind is P equals to FV. If P is constant and if we are looking at the relationship between F and V, the idea is that both of these are inversely proportional. Right? I would write this as F equals to P over V, and P is a constant, so it's just inverse proportion, and the graph for inverse proportion looks like this. A downward sloping curve with decreasing gradient which touches neither of these axes. Alright, 17. A block is released from rest and slides a distance x down a straight slope. Slope is at an angle theta to the horizontal. Slope is frictionless and air resistance is negligible. Acceleration of free fall is g. Which expression gives the final speed of the block? So again, there must be some weight of this block. So if this is the weight mg, so the idea is that this component is always the sine one and this one is cos, which I don't even really need in this question. So there is this mg sine theta, and is there any friction? There is no friction. So this is the resultant force mg sine theta, which would equal ma. M's cancel out, so the acceleration is g sine theta. But this is not what the examiner wants. It wants the final speed of the block. It's released from rest, so u is 0. Acceleration I just found out. I also know it goes through a distance x, so I know s is x. I want to find out v. What equation of motion do we use here? It's very obvious. We use v square equals u square plus 2as. So no u square here really. So it's just root of 2as. So 2x and that g sine theta. So that looks like option B here. '18, what is meant by the spring constant of a spring? So force required per unit extension, pretty easy, D. 19, a child holds a thin metal wire that is attached to a kite. Graph shows how the extension of the wire varies with tension. Keep in mind that extension here is in millimeters. A gust of wind increases the tension from 100 to 150. What is the change in elastic potential energy of the wire caused by the gust of wind? So 100 to 150 means it goes from here to here. Again, a couple of ways you could do this. You can also just do the area under a force extension graph, which is what we really have here. Or you could also do the calculations, right? Again, it would yield the same answer. So if you do half fx and you take their differences, so if I look here, the new one is 150 and the extension was 0.45 corresponding to that, minus half times 100 times 0.3, right? So you just calculate this, and the answer for this one is supposed to be B. Again, why did I not convert this milli here? Because the answers are also in millijoules, so the units even out. Question number 20, a microphone detects a sound wave. Microphone is connected to a CRO. Shape of the trace on the screen of the CRO is shown. Which property of the sound wave can be determined by using only the measurement of a horizontal distance on the screen and the value of a control setting? So remember that the horizontal distance corresponds to the time period or the frequency, which you can get by multiplying it by the time-based setting. So you can get the frequency, which is B. So we're done with almost half the paper, and I think I only saw one slightly tricky question. Not really all that difficult. 21. A longitudinal wave is traveling from left to right. The graph shows the variation of the displacement of particles with distance along the wave at one instant in time. Displacements to the right are positive, displacements to the left are negative. Which labeled point represents a compression? So with a longitudinal wave, you guys obviously know there's no up and down. Instead, it's left and right, with right being positive and left being negative. So which labeled point represents a compression? So with compressions, if you guys recall this, compressions is where the particles are closer together than the other, than what the mean spacing is, right? Rarefactions are where they are further apart. Compressions are where they are closer together. So in this case, if you look at this, where are the particles closer together? Again, how do we look at this on a displacement distance graph? So if you look at this, this is where the displacement is 0. This is also where the displacement is 0. This is also where the displacement is 0, right? For a compression, how do we talk about where this compression would lie in terms of a displacement distance graph? Because if it's displaced to the right, then it's going to be positive. If it's displaced to the left, these are negative. But at compressions, the idea is that the displacement on a displacement distance graph, this would be 0, right? There would be no such displacement here. So if we look at this one, it must be either B or D. But what are we then looking for? If we are looking for a compression, right, so this means particles are closer together. So this must mean that as we are going towards a compression, particles are getting closer and closer. So the displacement must be reducing. That's what makes the answer B and not D. If we are going in this direction, then the distance between them is increasing, and D would actually be a rarefaction. B is the compression, D is the rarefaction, right? So this is how you do this one. This was slightly a question that you had to think about a bit. Source emits a sound wave of constant frequency f. Wave is subsequently received by a stationary detector y. Frequency of the wave detected by y is less than what was emitted f. What is the reason for this? Again, it's pretty obvious that this question is on Doppler effect, and this is if the source is moving away. So if x is moving away from y, this causes a reduced frequency. Again, if it would be moving towards, it would lead to an increased frequency. Question 23, a beam of visible light is in a vacuum. What could be the frequency of the light? Again, in a question like this, you need the frequency. If you look at the options, all of these have these 5s with them, but the powers of 10 are different. You use V equals to F lambda here, obviously, to figure out what the frequency is. And again, you don't really have to use this. I have to use this because I have memorized the EM spectrum in terms of wavelength. So V is basically 10 to the 8, right? Or if I'm just working with the order of magnitudes, I'm ignoring the 3.0. F is what I want to find out. And the order of magnitude for visible light is in 10 to the negative 7 meters, right? So if I find out F here, which is going to be 10 to the 8 divided by 10 to the negative 7, so 8 plus 7, so we are looking for 15 basically. The closest thing here is 14, right? Which makes sense because there could be a difference because of how large either of these values are. So it could go 10 to the 14 or 16 or 15. But again, this is what it is. 24, a vertically polarized beam of light of intensity I0 is incident normally on a polarizing filter. Transmission axis of the filter is at 45 degrees to the vertical. The beam of light transmitted by this filter is then incident normally on a second filter. Transmission axis of the second filter is horizontal. What is the intensity of the beam after the transmission through the second filter? All right, so we have vertically polarized light coming in. So this is the angle that the transmission axis makes with the vertical. So this would obviously be I0 times cos 45 squared, right? So this is cos 45 squared because of the first filter. And then what about the second filter? The idea is that this light, which is now going to be coming out of the first one, is going to be polarized in this direction. Again, we are looking for the angle that it makes with the transmission axis, which is 45 degrees again. So this would be times another cos 45 squared, right? So it's basically cos 45 to the power 4. I don't have a calculator, and thankfully I remember this. Cos 45 is root 2 over 2, so to the power 4 would make the numerator 2 squared divided by 2, 4. So it would be 1 over 2 square. So 1 over 4 is B. Again, ignore the math if you don't like this or if you can't appreciate this. Just do this on your calculator. 25. A stationary wave is formed by two progressive waves traveling in opposite directions along the same line of travel. Which statement about the two progressive waves is not correct? They have a constant phase difference. This is not correct. Because when they are traveling in opposite directions, the phase difference is constantly changing, which is basically causing points of max and min amplitude. Points of max amplitude, you guys know, we call antinodes. Points of min amplitude, we call nodes. They must have the same frequency, same wavelength, same speed. All of these are requirements for the formation of a stationary wave. Alright, 26. Sound from a loudspeaker placed above a tube causes resonance of air in the tube. Stationary wave is set up with two nodes, two antinodes as shown. Tube is height 60 centimeters. Speed of sound is given. What is the frequency of sound? So you can see node node and an antinode. So this is half a wavelength, and node to antinode is quarter. So this is basically 3/4 of the wavelength, which is equal to 60 centimeters, so 0.6 meters. So I can find out what lambda is from here. So 0.6 times 4 over 3 is 0.8 meters, and then I can just use V equals to F lambda here. So 340 equals to F times 0.8. So 340 over 0.8 looks like 430, because the actual answer is 425. Question 27. A continuous progressive water wave in a ripple tank passes through the gap in a barrier and diffracts. Width of the gap is greater than the wavelength of the wave. So just reading this statement, I know this is not the optimum case for diffraction. Which change causes the wave to spread over a larger angle as it passes through the gap? So if the width is greater than the wavelength, either you increase the wavelength or you decrease the gap, right? So if I look here, a small decrease in the wavelength, this is not going to increase diffraction. It's not going to make it spread over a larger angle. Decreasing the width of the gap is true, right? A small increase in the frequency of the wave. If the frequency of the wave goes up, again the wavelength would go down. So this is not what we're looking for. And height of the barrier has no effect whatsoever on the diffraction. Question 28. A diagram shows a view from above of a double slit interference demonstration. L is a monochromatic light source with a vertical filament. Alright. B is a barrier with two narrow vertical slits, and S is a screen upon which the interference fringes form. Interference is I at the point on the screen where the center of the bright fringes form. When one of the slits is covered, what is the intensity at the same point on the screen? So the intensity here is basically formed because of the interference of these two, right? So you have a bright fringe formed here, where basically you have a max amplitude. So you can say that for each of these cases, if this is amplitude A, if this is amplitude A, the amplitudes are added up, which gives you some amplitude here, right? Which is basically double. So if you have now a case where only you have light going through from one of these, right? So light now only goes through from one of these slits. So now the amplitude has basically halved. And in doing so, you now need to recognize this relationship which is at play here. So if amplitude is halved, the intensity would be half squared. It would become 1/4 of its actual value, right? So it would be squared. It would be half squared, so it would become 1/4 of its actual value. Question 29. Green light of wavelength 550 nanometers is incident normally on a diffraction grating and produces a diffraction pattern. Place 3.5 meters from the diffraction grating. The third order maximum on the screen is at a distance of 0.75 meters from the 0th order. What is the distance between two adjacent slits? So it's basically asking me for D. And if you remember the equation, you know that we need n lambda. So d sine theta equals n lambda. I also know n is 3. I want to find out d. I know lambda as well, and I need theta. And theta you will find using basic trigonometry, right? So from here you can see that this is the adjacent, this is the opposite. So we are going to use tan. So tan theta equals opposite over adjacent. And then you just take the tan inverse, you get theta from here. And then you plug that theta into here and you find out D. Again, this is not really a difficult question. Somebody who has done even a bit of practice can probably identify that you need to find theta here. So the answer is supposed to be C, 7.9 into 10 to the negative 6 meters. 30, which charge can be carried by a charged carrier? So the idea is the quantization of charge, that it has to be a multiple of the fundamental charge of an electron, which is 1.60 into 10 to the negative 19. Obviously can't be A, it can't be smaller than the fundamental charge. 4 into 10 to the negative 19 is not an integer multiple. This is not. Right? So the answer to this one is C. 31, a resistor of resistance R is connected across a cell of EMF E and negligible internal resistance. Which single change to the circuit would lead to the largest increase in the power dissipated in the resistor? So resistor is of resistance R and there is negligible internal resistance. Which single change would lead to the largest increase in power dissipated in the resistor? So there is basically just a circuit where you have a power source which has EMF E and you have a resistor. Now it's asking for what change is going to cause the largest increase in power dissipated. Now you guys normally know how I approach power questions, because here there is no mention of current, and if I look at the options, all which is mentioned is either the EMF or the resistance, so I know that I would have to use this formula. Alright, nothing to do with current here because the options also don't talk about that. So doubling the value of E, doubling the value of R, halving the value of E, halving the value of R. So now here if you look at this, you can probably see that to cause the power dissipated to go up, you should increase V or you should reduce R, right? So increase V or reduce R. But what out of these two? Again, the idea is linked to proportions again because of this square here, and this V is really equal to E because both of these also form a parallel circuit. All of the EMF here would be appearing across the only other thing in this circuit, which is the resistor. If I would double E, because of the square, power would increase by a factor 4, which is why A is the answer. Halving the value of R would just cause the power to double, but this doubling of E causes the power to quadruple, right? So A is the answer for this one. 32, an electrical cable is made up of one thick strand of copper wire that is surrounded by 8 thin strands of copper wire. All 9 strands of wire are connected in parallel with each other. A cross section of the cable is shown. So these are 8 identical strands which have cross-sectional area A, length L, and a thick strand of wire which has cross-sectional area 4A and length L. The cable has total resistance R, which expression gives the resistivity of copper. So R equals rho L over A. Let's first write this down and then think about this. So all of these have lengths L, right? And we need to find the resistivity. So how do we go about doing this? All right. So how do we go about doing this? So first of all, you see you have these, what do you call it? You have these 8 parts of cross-sectional areas, and then you have this one. And all of these have the same length L, so at least I don't need to worry about L. If I think about the cross-sectional area, I can see that all of these are basically connected in parallel, right? So it's very easy to also identify this, that really this is pretty much like a conductor which has a simple cross-sectional area of 4A and then 8A because of these. So it's really just R equals to rho capital L over 12A. This is the easiest way to do this, right? And now from this you just need resistivity, so that's going to be 12RA over L. All right, so then you just select this one and that's your answer. All right, you guys can also probably identify that this would definitely not be the answer, because if you also just look at the units, they don't match up. It would be meter square over the meter, so it would be meter per ohm, which is wrong. It should rather be ohm per meter. So even on that units analysis, you would be deciding between C and D. A car has sensors for detecting light intensity and temperature of its environment. The sensors make use of an LDR and a thermistor. Car moves from a warm and dark environment into a cold and bright environment. What are the changes to the resistance of the LDR? So warm to cold, temperature decreases, resistance must increase of the thermistor. And dark to bright, light intensity increases, resistance must decrease. So it's C. Again, pretty easy. (34) A student assembles a circuit shown. Which row describes the state of the two lamps? So because this is positive, current would flow like this. So lamp 1 would definitely be on because current flows downwards through it. And basically about lamp 2, you know this one would be forward biased, this one would be reverse biased. So current would flow through here and through the lamp. So this one would be on as well, right? You can in a technical way state this, that this diode basically shorts this one. 35, Kirchhoff's law is a conservation of which quantity? First law is charge, second one is energy. 36, three identical cells each have EMF E, negligible internal resistance. Cells are connected to three identical resistors, each of resistance R. What is the potential difference across one of the resistors? So in this case, some people might like to use KVL, but there is also a way which avoids doing that. If you just look at how the cells are connected. For the EMFs to add up, we know a positive must be connected with the negative. So there's E plus E, because these are connected correctly, right? Positive to the negative, so this makes it 2E, but then the positive is connected with another positive. So this is E plus E minus E. So in a way, both of these cancel out each other and the EMF is only E. Then you have three resistors in series which are sharing this EMF E, so the EMF would be equally divided along each of these. So E by 3 would be appearing across each one. You can also do this using KVL, but this is obviously much easier. All right, 37. In the potentiometer circuit shown, the reading on the ammeter is 0. The LDR is then covered and the ammeter gives a non-zero reading. What change could return the ammeter reading to 0? So first let's try to understand why the ammeter reading was previously 0 and now it becomes non-zero. So if the LDR is covered, this means that the light intensity which reaches it reduces. So its resistance goes up, and basically because of voltage division, the voltage across it also goes up. And because the voltage across it goes up, there is now a potential difference which causes the current to flow. What change could return the ammeter reading to 0? Decreasing the supply voltage. If you decrease the supply voltage, there will still be this difference in potential difference between these two. So the current is still going to be there. So A is wrong. And similarly, by the same logic, B is also wrong. Moving the sliding contact to the left. So if right now this resistance has gone up, the voltage across here is more, you would also want the voltage across here to increase so that there is no more current flowing here. So for the voltage to increase, you would want the length of this wire to increase. So yes, this must be slided out to the left so that this length increases and hence the voltage increases and there is no more potential difference between these two. So this is true. And this one would again, by the other reverse argument, this would not cause the ammeter reading to be 0. 38, what are isotopes? So nuclei of the same element and same number of protons, different number of neutrons. So that's C. 39, a neutron is fired at a nucleus. Neutron is absorbed by the nucleus, which then splits into these barium and krypton nuclides. What is the number of free neutrons emitted when this splits? Again, it's pretty easy to see, but if it helps, then write out this equation. So there is this uranium 235 92, which is struck by a neutron, which gives us barium 141 56, krypton 92 36, and we need to find the number of neutrons, which are these, right? X is the number of neutrons. You didn't even really have to use with the proton number here. You can just use the conservation of nucleon number. So 235 plus 1, if I write this out as an equation, so 236 should equal 141 plus 92. Let's find out what that is. So 233, and then you have X times 1 as the contribution to the nucleon number that the neutrons have, right? So X turns out to be 3. So that's the answer here. 40, a pi positive meson has a charge of positive E, where E is the elementary charge. It consists of an up quark and one other quark. What could be the other quark in the pi positive meson? So if it is an up quark, then remember that UCT, all of these are positive 2 by 3 E. So for the total to be positive E, there must be another positive 1 by 3 E coming in, right? So we know that if UCT is 2 by 3, then all of the others, which are down, strange, and bottom, all of these are negative 1 by 3 E. And for this negative to become a positive, I am really just looking for an anti-quark. So anti-down, anti-strange, anti-bottom. So anti-down, the first option, that's what we're looking for, right?